we're going to be graphing systems of linear inequalities. Before we start, we need to know a couple symbols. The less or the greater than or less than sign. When you see those, you need to put a dotted line on the graph. And when you see the greater than or equal to or the less than or equal to sign, and you need to put a non-dotted line on the graph. And in any greater than sign, greater than or equal to or just greater than, you need to shade above the line on the graph. And for the less than or equal to or less than symbol, you need to shade below the line. For the first example, we're going to graph the inequalities of these equations. And when you do, it will look like this. And this line right here is the first equation because it's dotted. You can tell because it's dotted, and the first equation has just a greater than sign. And this line right here, that's the second equation because it has the less than or equal to sign. And since it's equal to, it's not dotted. For the next example, we're going to take these equations, but if the y isn't isolated, like it's not isolated here, you have to isolate it. And so for the first equation, we'd go through these. Equations to get the final one right there, and then for the second equation, we get this. And then you'd graph these two equations on the graph, and it would look like this. The graph would look like this. And yeah, it's pretty much the same as the first one. And the solutions is where you shaded, or double shaded, right? Okay, and for the third example, we're going to be finding the solutions again of these problems right here. Since the y is already isolated, we don't need to do anything. And okay. And so the graph for this equation will look like this. And see how the shaded regions don't intersect at all. They don't overlap. That means that the graph would be no solution. And so there would be no solutions, and yeah, that's it. And for the last example, we're going to find the solutions of 3 inequalities. And so for these things, the y's are already isolated, which is easy for us. And so the graph would look like this. There's 1, 2, and 3 equations. And it's only a solution if all the equations that are listed, if all their shaded regions intersect. So like this right here, this part right here is double shaded, but since there's 3 equations, it doesn't count. It'd have to be triple shaded, like this section right here. And that's the only part that has the solutions to the problem. And that is it. Thank you.